Hello guys, today we are going to start another topic which is a part of 3D geometry. Previously we have looked into lines, straight lines. We have done how to find the equation and everything. If you are unaware, I will share the links in the description. You can go and check out those videos. Now let's start with plane here. So what is a plane first? A plane is a surface which will be made if I have a if I have three non-collinear points on that surface. Then I can, if I pass lines through those three non-collinear points, then I will get a plane. Okay, so you can try on your copy, put three dots anywhere. Okay, but they should not be collinear. Collinear means on the same line. Okay, they should not be on the same line. So you put three dots and then join them. You will see that you will get a plane. So we will be getting the we will try to find the equation of plane in different cases. Okay, so the first one is equation of a plane in normal form. Okay, so the normal form means this normal which is written here, that will be given to you. Okay, and the distance from the origin will be given to you. You see, but I've written normal to the plane and distance from the origin d is given. Okay, so now to visualize this three axis, I would tell you to look at the corner of your house where three walls come and meet. Okay, you will have a situation like this. Okay, where two walls come and meet and this is your floor. Okay, so you look at the lines where they meet. Okay, now you remove those walls from there and just look at the lines. Then you can imagine a xy z axis. Now on that xyz axis, if I keep a plane like this, then I will have 3 points where this plane is touching the xyz axis, and if you join them, you will get this triangle. Understand? So basically I'm talking about this plane, but this one is touching the xyz axis, so that's why we are highlighting it here. Okay, now you see, I take a random point P on the plane, on top of the plane, and as I said, normal to the plane and distance from the origin is given. Okay, so normal is from the origin, this one. The normal means perpendicular. Normal means it should be perpendicular. Clear? So it's perpendicular to the plane and distance d is given. Okay, this d is given. Now if d is given and your n vector is given, suppose n vector is given, now if I find n cap and multiply with this d, okay, then I can get the vector. Okay, then I can get the vector. Now you can see here, I made a little change here, this one. Okay, so you see, given is the normal vector n vector, so n vector will be much bigger, maybe. Okay, it may be bigger. Okay, it may cross the plane. Okay, it can go through the plane and it can come out. So but if we have the distance d from the origin, then I can find, suppose this is n vector, I can find n cap and multiply with d to get the distance, to get this distance, right? So that's what I have done here. So given is the normal n vector, n cap is its unit vector. Suppose n vector is the bigger one, the longer one. Okay, n cap is its unit vector, so on will be d into n cap. Right, now you look at the triangle OPN. OPN triangle, if I use triangle law of vector addition, you can clearly see, and you know also, that OP plus PN should be equals to ON, right? So what I have written here, according to the diagram, you can see according to the diagram what I have written here, OP plus PN equals to ON, and this, the point which we have considered, we always take it as R, right? And the other one, ON, can be written as this, right? So I have substituted it here. Clearly see that R I have substituted, PN I kept it just like that, and then I wrote ON. Clear? Now I got my PN. Okay, I got PN. Now what is PN? PN is a vector lying on the plane. So once I get that plane, I can see that ON is perpendicular. Yes, this ON is perpendicular to our PN. Yes, we already know from the beginning. So if they are perpendicular, their dot product should be 0. So what I have done here is take their dot product and substitute their values. You can see clearly, substitute their values. So once you substitute their values, you can see when you look at this step, d into d will be d square, and n cap into n cap will be modulus of n cap. Okay, we have seen in vectors. Okay, then minus r vector dot dn cap. Okay, so now I take d common, and magnitude of this n cap will be 1. So if you solve it, you will be getting an equation like this. So this is your vector form. This r is a random point on the plane, this n cap is a unit vector of the given normal, and d is the distance of the plane from the origin. So this form is called the normal form of the equation of plane. Okay, one more form we write it. Suppose you can check this one, write a note here, then we'll come back to this. Okay, so if I have an n vector like this, the normal vector like this, okay, so how do we find its unit vector? You find its unit vector by dividing it with its magnitude. Okay, so once you separate, this is the LCM for all of them. So once you write a by square root of a square plus b square plus c square, this becomes what? This is L, direction cosine, right? Similarly for b, similarly for c. So I will be getting my equation for n cap like this. Okay, so whenever you are writing a vector, its unit vector will give you the direction cosines. Okay, the vector gives you the direction ratios, and the unit vector gives you the direction cosines. Okay, now sometimes your equation vector form will be given in this form. Okay, and sometimes it will be given in this form. So when it is given in this form, don't say p is the distance from the origin. Okay, if you see a vector here, then you will not say this is the distance. Okay, if you see a unit vector here, then you will say this is the distance. Clear? So let's see the comparison between these two. So you can see here we have a comparison between this thing is the distance from the origin, and then n cap is the unit vector of normal n vector. So you understand from where is that n vector, right? It may be a long vector which crosses the plane, it may be a small vector which it doesn't even touch the plane. Okay, but d is the distance of the plane from the origin, and then r is the random point vector formed by the point on the plane. Clear? So this is exactly our equation of the plane in vector form, but this is also the equation of the plane in vector form, but this is not the distance. Okay, sometimes if they ask you that what is the distance, you will not say this is the distance. If you see a vector here, you have to have a unit vector here. Okay, so now see here what is given here. This is just a constant, this is not the distance. So to get distance from the origin, divide n vector, that is d, you have to divide this p by modulus of n vector. Clear? And this is your normal vector, this is same point. Okay, so that is how you will find your vector equation of a plane. Now let's see its Cartesian form. See Cartesian form for both the cases. Okay, now if you have n vector, this gives the direction ratio, right? So r, whenever we have to find the Cartesian form, we take r as xi plus yj plus zk, right? We substitute here, and you will say when you take the dot product of this one and this one, you will get ax plus by plus cz equals to p. Okay, dot product you know how to take, because if you have seen the previous videos, then you should be able to do that. Okay, if in this case where we have n cap, we have direction ratio cosines in place of this. So see, so if you multiply them, you will get lx plus my plus nz, no problem. Dot product you know how to take. Okay, here abc are the direction ratios of the plane. Okay, and here lmn are the direction cosines of the plane. Remember that whatever is the direction ratio of the vector is also the direction ratio of the plane. Whatever is the direction cosine of the vector, unit vector, that is also the direction ratio of the plane. Clear? So you should keep in mind that direction ratio of the normal vector and direction ratio of the plane will be same. Direction cosine of the normal vector and the direction cosine of the plane will be same. Okay, now let's see an example on that. Okay, now you can see I've written a question. Find the vector and Cartesian equation on the plane which is at a distance. So d is already given to you from the origin. Yes, without reading this, don't say that it is d, because it is from the origin. Okay, so distance from the origin, and its normal vector from the origin is this. So normal vector means n vector is given, right? So your equation is, so the equation is, how do you write the equation? This is our equation. Yes, so directly don't substitute this and this. Clear? It will be wrong because we have n cap here and we are given n vector here. This is our n vector, right? So what I will do, I will find my n cap first. So d is given to me. So see, according to the question, d is given to me, n vector is given, so I'm finding n cap. How do you find n cap? N cap is n vector by modulus of n vector, right? And then just split this denominator to each term. So you can see this I got as n cap. Okay, now I'll be substituting them in the equation. So see now vector form. See this vector form. This is what you got before. This is your n cap. So I have written here. If you directly write r vector dot 2i cap plus 3j cap plus 4k cap equals to 6 by root 29, then it will be wrong because you have to find n cap. Now once you have written it, that is your answer in vector form. Now for getting the Cartesian form, I said always change it to xi plus yj plus zk. Okay, so once you change it, you can see you can multiply them, and then ijk will go away because it is a, if we need the vector form, then only you will have ij, I cap, j cap and k cap, but here it is Cartesian form, so we will not have. So you multiply them, take LCM, you multiply, you take dot product. Okay, then you'll be getting like this, and 29 is LCM for all of them. You can cancel it and you get the answer. Okay, so that is your answer. So the next thing we'll be doing is equation of a plane. The next thing we will be doing is equation of a plane perpendicular to a given vector and passing through a given point. Okay, now in 3D you need to know that diagram is everything. Understanding and visualizing the diagram is everything. So if you understand that, if you understand the figure nicely, and if you can relate the questions to these figures, then you can do the problems easily. Now you can see I have a plane like this. This is my plane. I told you how to visualize this plane. If you put a plane like this, okay, then you will get a triangle if you join the points where the plane is touching the axis. Okay, now let's see. It's a very easy figure, okay, because we already have a perpendicular here and we have a line here. If we have the dot product, then we should get the relation should give us the equation of this plane. So in triangle OAP, you can see in triangle OAP, this one, you see I use triangle law of vector addition again. OA plus AP, OA plus AP should be equals to OP, right? So I have written it here. Remember, this unknown point, whenever we take it as R, okay, and the known point is always as A, then the second known point will be B, and the third known point will be C, like that. So you see clearly, you can clearly see that AP I will try to find with the help of O, A and OP, which are given to us position vector. Now AP, you can see OA is A and OP is R. So I can substitute them and then get this equation. Now I know that my AP, you can see AP and this line are perpendicular because AP is lying on the line or on the plane. AP is lying on the plane and this line is perpendicular to AP. So their dot product should be 0. So I have written it here. From figure, N is perpendicular to AP. Yes. So their dot product should be 0. So I have substituted AP as R minus A into N vector. Okay, see previously our N vector was from the origin, so we took it as small n vector, right? Okay, here we are having from some other point, so we took it as capital N vector, but know that there is not much difference between them. Previously also that vector has a direction ratio ABC. Here also it will be having direction ratio of ABC. So now here see here, so if their dot product is 0, okay, and if the perpendicular vector is given to us n vector, okay, then their dot product should be 0. So this is your vector equation. Okay, we are not writing this n because we already know it's given, so we can find R minus A, then we can use that form and take dot product, we will get the equation. Now let's come to Cartesian form. Cartesian form, you just put your R. From here you can see your R can be, the position vector of R can be written as xi cap plus yj cap plus zk cap, and position vector of A can be written as xi x1 I cap plus y1 j cap plus z1 k cap, and n is already given to us. So I just substitute them, and after substituting I will be getting R minus A. Look at R minus A. Okay, R is this, A is this, so R minus A will be x minus x1, y minus y1, z minus z1. Okay, so you can see here I have written, and take their dot product. So I will go, k and j will go, k will go, and then this is our Cartesian form. Now let's do a problem on whatever we have found, the vector equation, Cartesian equation. So be familiar with the type of questions, the things which are given and which you can use it. Okay, so find the vector and Cartesian equation of the plane which passes through the point 5, 2, minus 4. So point is given, so A is given to us, and perpendicular to the line with direction ratios this. Perpendicular to line means plane is perpendicular to the line and line is perpendicular to the plane, is the same thing. Okay, so and perpendicular to the line with direction ratio this. Okay, So and we know that the direction ratio of plane as well as the line are the same, yes, which is perpendicular, right? So our a is given to us, and our n vector is given to us. So I will just substitute them in my formula. So we know the formula is this, okay, given this point. So if the point is given, we get the vector as this, and if direction ratios of the perpendicular is given, or if the plane is given, the direction ratio of the line also will be same, which is perpendicular. Okay, so n we got, and then we just substitute here in this equation here, okay, r minus a dot n vector is equals to 0, right? Now if I need to find the Cartesian form, what you will do whenever we are asked to find the Cartesian form, we take r as xi cap plus yj cap plus zk cap. Okay, so you substitute here. You can see if you if you put this here, if you put this one here, okay, so then it will be x minus 5, which you can see I cap. Okay, in copy you try writing r in place of this, okay, so you will get this. You combine I together, jj together, so you'll be getting this, and take dot. So when you take dot, you multiply, and after solving you'll be getting this. Okay, so the problems like this you can easily do with this formula. Now let's go to the next topic, equation of the plane passing through three non-collinear points. Okay, so now here you need to understand the diagram nicely. Okay, so what I have done, I have drawn xyz plane. Please write it. This is x-axis, this is y-axis, this is z-axis. Okay, this is z-axis. Okay, now the diagram which I made with the red pen, that represents our plane. Okay, and the vectors which you can see, or the line which you can see with red, those are the line on the plane, and the black lines which you can see are the position vectors from the origin. Clear? So you can see now I have 3 points are given according to our this thing heading, equation of a plane passing through three non-collinear points. So non-collinear, why non-collinear? You can think this point and this point, if they are collinear, I can have many plane passing through them. Okay, one will be like this. Now you rotate this on this axis. Suppose these 3 points are lying on this line. You rotate this plane on this axis, so you will have different planes rotating like this. It will rotate. Suppose 3 points are here, 1 2 3. Okay, they are in a straight line. I can just rotate them. I'll get millions and millions of planes on the same collinear points. Okay, so that's why it's non-collinear points. Okay, I hope you understand. Three non-collinear, suppose this is a line. Okay, imagine that line is here on my hand, and this hand is my plane. All the 3 points are lying on that line. Now if I rotate, this is my first plane, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So as many I can make from them, so you will not have a unique equation. So to get a unique equation for the plane, you need to have three non-collinear points. Okay, now you see this is x, this is y, this is z axis. Okay, now look at the diagram very carefully. We are just taking dot product of two lines here, and then the relation between them will give us the equation. I have rs on the plane, I have rs line on the plane, I have rt line on the plane. Okay, if I take their cross product, okay, if I take their cross product, what will be our cross product? We are not going to that sine theta thing. We'll just write the cross. Okay, here you can see here. Okay, but we are concerned about the vector which will come out as the resultant. Okay, so you use your right hand thumb rule. You will keep on RS like this, RS to RT. Okay, then you'll check your thumb. So you'll see the thumb is perpendicular going up. Okay, so that perpendicular will this line will be perpendicular to both the vectors here. Okay, so the line which you can see here, this one is perpendicular to RS as well as RT. Okay, now if I have one perpendicular line on the plane, that means this line will be perpendicular to the whole plane. Whatever line you draw on the plane, draw a line here, draw a line here, draw a line here, draw a line here, line here, anywhere you draw, this line will be perpendicular to it. Okay, so the idea is I will get a vector which is perpendicular to these two lines. Okay, both the lines and both are lying on the plane. That means you draw anywhere a line that will also be perpendicular to this line. Clear? Okay, now you look carefully what I have done. That was the case, and those were lines on the plane. Now you see the position vector. So if I have P as XYZ position vector, I put it as R, and you know very well how to write the position vector of P. Then position vector of R also you can write, yes, capital R, position vector of capital R also you can very well write. Position vector of S you can write. Position vector of T also you can easily write. Okay, so I took them as R, A, B, C. Now let's see its vector form. And now you see what I have written. Using cross product from RS to RT. Once you have drawn the diagram, you look at this. The vector perpendicular to RS and RT lying on the plane is this one. Yes, we know. Since RP is also lying on the plane, RP is also lying on the plane. You can see clearly in this RP is lying on the plane. It's red color. Okay, so that means it will be perpendicular to our vector which we got. So then RP is perpendicular to this. So their dot product should be 0. Okay, so how I'll find RP? How I will find RP? Look here, RP, this line. So position vector of P minus position vector of R, right? So that can be written as R minus A. Similarly, if I want to find RT, position vector of T minus position vector of R, right? And if I want to find the if I want to find RS, then it will be position vector of S minus position vector of R. Okay, so you can see directly for RP I can write R vector minus A vector, right? For RT I can write C vector minus A vector, and for RS I can write B vector minus A vector, right? Okay. Now see what I have written, and this is just to make you understand I have written, otherwise I would have written this one directly. So this is for explanation, and for them I have written directly. So this is your vector form of equation of a plane passing through 3 points. So for a question, if you see that the 3 points can be found for a plane, then you will be using this one to get the equation. Now let's see the Cartesian form. The Cartesian form, if you do 2-3 times, you'll easily understand what is there. And before that, let me tell you this. This what we got here. This is called the scalar triple product. Okay, I'll be making a separate video on scalar triple product. Okay, but let's do what is relevant to your syllabus in this video. So in scalar triple product, we have 3 vectors, 1, 2, 3, and when we have to solve them, okay, we just write them in determinant form. Okay, and the Direction ratios of the first vector is written here, ratio of the second vector is written here, direction ratio of the third vector is written here, and then we solve the determinant, we get the answer. Okay, so remember that is scalar triple product of three vectors, because see x minus x1 you will get from, if you have r minus a, what are the direction ratios? R is x, y, z, right? And this is x1, y1, z1. So if you do r minus a, you will get x minus x1, y minus y1, z minus z1. So I have written here. See? Yes, you can see I have written it here. So similarly for second, for third vector. Okay, so if you put it here, you will get the equation for the plane. Now we see the equation of the plane in intercept form. Okay, this is a very simple topic, that's why this will be fast. So as we know, in class 11 we have done intercept form like this, which this is my x-axis, this is my y-axis. So we have x by a plus y by b is equals to 1. This was our intercept form in class 11, right? Because we have two dimension there. Now one dimension has increased, so this is my 3 dimension. So I just extend it to a third coordinate. Okay, so z by c is equals to 1. Solving is not required. It's a very simple idea to remember this. You can just remember it, because in linear programming you have seen how to write the intercept form of a line, right? So you can extend it in 3 dimension also with the third, right? So this much for this video. In the next video we will be doing equation of a plane passing through the intersection of two planes. Okay, I am purposely making another video for it, because mostly questions are asked from that concept. So I'll be starting afresh from there. Thank you.